So through a little bit of magical persuasion here, I was able to straighten these bolts out enough to where I can get them in and out by hand now, which is all I ever wanted, just to make my life a little bit easier. So I'm prepping this area of the frame rail here for welding these engine mounts on, and whatever type of bed liner they used on this is awfully difficult to get off. It doesn't really grind off easy. It just kind of melts and smears. You can see there's still like a dark layer of it on there where it's just smeared, and I need to get it all the way off for welding. And trying it with a wire brush, it comes off a little bit easier, but it still gets hot and melts and doesn't come off all the way. So I need to get a nice clear area here for both mounts for welding. And this is the mount. You can see the difference. The old ones didn't have this leg here, and you can see kind of difficult to get in. There's a real specific way. You have to notch this over first, and then that bottom leg here falls underneath, and then it kind of twists into place. I'm not sure the exact location forward to back yet because I don't have the engine in, and that's gonna determine it, because this frame rail is actually very curvy, so the two mounts are quite different. There's a lot more standoff on this back mount because of that curve in the rail, and the engine is square in the chassis. It doesn't follow that curve or that taper of the rails. So a little more cleanup work on this, and then I'm gonna head to the other shop, pick up the cherry picker, and we're gonna lower this engine in this chassis for the first time ever, hopefully. Fingers crossed. Oh, and I got this brake line tab removed. It was just a brake line mounting point for hard line to soft line. So that's gone. I'm gonna have to redo the brakes in this car anyway, because this is really all I've got. I may have just found the best way to remove this undercoating or bed liner or whatever it is. Not very scratch resistant. In the last video, a couple people commented, why don't you just flip the airbox the other way around and run it? And I tried that with the scan data. I flipped it and I looked at it, and it would take a little bit of firewall clearance to make it clear. But the big issue was this plug right here is the throttle potentiometer, I guess. So this bike's a little weird. It has a regular cable throttle that runs from the throttle tube right here to the sensor. Now the sensor runs to the ECU, and then the ECU runs to this, which is an electric motor that actually controls the butterflies. The reason it's this complicated is because it's ride-by-wire, but it has different throttle maps. There's like A, B, and C mode, which I guess C mode is like rain mode, where it softens the throttle input to where if you just crack the throttle open some, it smooths it out to give the rear tire a better chance for getting traction. The other thing is I have a Bazaz tuner that was on this bike that helps with, somehow it's supposed to be traction control, but it never worked. And I don't know if it takes front wheel speed versus rear wheel speed or what. I have no idea. But I just know it never worked. But here's the issue. There's this big plug here. I don't know if you can see it. This plug here, and then you plug in, the wire sticks up to about here. Well, with this air box, when you try to flip it, here's the plug. All right, that plug's already bottomed out without anything even plugged into it, and we're nowhere near where we need to be sealing. So possibly with some extensions, we might be able to run it upside down, but I think at this point I'm just going to order the Legends airbox air filter thing, because kind of just, this is all just a big hassle, and I'm not sure if it's going to help performance or not to have this airbox, depending on the volume. And this is actually the ECU, the computer, the brain to run this engine. It's kind of funny that it mounts in the airbox like that, but oh, look at that. It's got a, I guess it has an aftermarket tune on it, number 359, 925, 2014, and they got a signature. If you know FC09s and no tuning, let me know who did this or what tune it is, because it also had an aftermarket piggyback Bazzaz tuner on it too. So that's interesting. Just now learned that. Had this bike since 2016, I think, and first time I've ever looked at that. Kind of neat. Well, there it is. It's where it's going to live. That went extremely well for the first time ever being put in place. It's amazing what happens when you have the scan data. You can design it all ahead of time because it fits in exactly like it's supposed to. I sound surprised. I shouldn't be surprised. I've been doing this long enough. But that was definitely the easiest I've ever been able to do anything like this. And I mean, even putting engines in cars that belong in there. But I'm pretty happy with it so far. So the mounts are in, but I couldn't help myself but go ahead and test fit this engine. I am going to pull it back out tomorrow and do a little bit more work. I've ordered a special tool to do some deburring. I love laser cut parts, but man, it leaves a nice sharp edge. And I spend a lot of time, it's not deburring because it's not a burr, but I spend a lot of time smoothing out those sharp edges so I don't cut myself on them later. And I bought a tool. It's basically just a router bit, but it's specifically made for doing stuff like this. So I'm going to try it out, see how it does, and give you my honest opinion on it. The problem with using actual router bits with carbide tipped cutting surfaces is the bearing that guides it is usually way too large a diameter, and you can't get in small tight radiuses. And I know I'm still not going to be able to get in the really tight spots like this, but I should be able to do most of everything. The one I ordered has a 7mm diameter bearing, so hopefully that'll be adequate. It's kind of dark in here, but let me see if we can get a shot of these mounts. Another thing you can see is the inclination of this angle of this engine. That logo in the bike is level. I can't remember the exact angle I had to set it at to make it all fit right, but I believe it's 30-ish degrees, something like that. But it's nothing major compared to a bike doing a wheelie. I am going to redesign the oil pan and give it a proper pickup for the angle it's sitting in the car. But that'll come later down the road after the test drive and after I know that this engine is well suited for this car and powerful enough, yada yada, so on and so on. But for a can't talk. For a first test fit, very pleased. Very nice. So it's now been 3 days since my new chamfer bit I ordered was supposed to arrive. Still isn't here. Hopefully it comes today. We'll see. But in the meantime, I want to get these engine mounts chamfered, but I can't because I don't have the bit. But for large parts, using a router is easy because you just run the router around the edge of the part. Small parts are a little more difficult because, well, it's kind of self-explanatory. Part moves around, that kind of stuff. So in the meantime, I'm going to use this piece of scrap and make a, I don't even know what you call it, but it's going to bolt to the router like that, and then this piece will bolt to the table, and I'll have a nice surface that I can run the parts around and chamfer and hopefully not lose my fingers. So we'll go ahead and start on that because I got nothing else I can do while I wait. Look what finally showed up. There it is. Metal beveling bit, deburred chamfer bevel. Router, battery powered or chorted. I don't have a chorted one, I have a battery powered one. Alright, let's take a look. So, this thing was about $100, which is really steep for a router bit, but I don't know if this is working or not. We'll zoom in on it. It's got indexable carbide cutters. So you've got 3 sides per insert. And what really drew me to this one was the tiny little bearing. I asked them and they said it was 7 millimeters. Yep, 275, so that's right at 7 millimeters. So we'll give this thing a shot. The other thing I was worried about was, I don't know if this will pick up on camera or not, there's a little bit of distance between the bottom of the bearing and the actual insert, the cutting edge. So I asked him if you could use it on 3/16 material, which is 188.188. So I knew I could probably use it on one side because the bearing will not fall off. But if you chamfer for one side and then you go and chamfer for the other side, the bearing has less material to ride on. So I'm going to try this thing real quick and see how it works. So I love this fixture table I've built, but one small issue I have with it when I'm using it as a regular table, sometimes I drop stuff and it goes right down through the holes into the abyss, never to be found again. So that is one drawback of using a fixture table as a regular table, but oh well. So I've dropped one of these and haven't been able to find it, but 3 should be sufficient. So if you look at this thing from the side view, I've got it set up pretty shallow, so it should be a very small little chamfer it cuts. And this will be the first test, so we'll see how it does. So, the smaller the bearing, the tighter the little radius you can get into. The problem is, if you give your part the same radius as the radius on the bearing, when you feed into that, it's going to grab all the way around at once, and it's going to not be happy. It's either going to bend the shank on the tool or chatter like crazy or something like that. So if you're designing, see, these are very close. That one's a little smaller than the bearing. That one's about the same. So if you're going to use something like this, I would design all your radiuses to be slightly bigger. So that's a 275 diameter bearing. So I would make all your radiuses at least 150 thou, so it doesn't simply grab when it gets in that corner. It's the same when you're machining anything, like when you're CNC milling anything, you always want the radius of the corner to be slightly bigger than the radius of the tool so it doesn't chatter and grab when it's in those corners. I didn't design this part to use this tool. This is the old motor mount. I designed this well over a year ago. The new ones I've also designed before I got this tool. You saw them on the car. But I want to run this little chamfer tool on them anyway, just to clean up these sharp edges. So we'll see how it goes, I guess. Trust me when I tell you, you don't want to hear the awful sound this thing makes. It is not pleasant, but it gets the job done. So I've got one part done, and I haven't done the other part yet to kind of show you the difference. And besides the awful noise it makes and the tiny little burrs that are the tiny little chips that get everywhere and burn you. That's why I started wearing gloves in that last one. Besides that, this thing is I'm happy with it. Again, the price is pretty steep, but I ended up ordering the one that came with all the extra bearing and 4 extra inserts just in case, just to have in case the company goes out of business or, you know, things happen. So I would at least have it and have the parts without having to source new ones. But it leaves a nice finish if you climb cut, which climb cutting with a router is the way it's trying to pull the part into the bit, but you have to let it pull it in slowly. So push down the part pretty hard on your plate and give it some friction, and it leaves a pretty nice finish. So this is an easy way to really spice up your laser cut parts and make them look a lot more finished. While the engine was in place, I went ahead and traced where the mounts went, just so I can go ahead and do a final prep for welding. I gotta say, chamfer on these parts really makes them look a lot higher end. I'm happy with it. I even tried it on a piece of 1/8 inch aluminum, and as set at this depth, I could do both sides. The bearing had barely any surface to ride on, but it worked, so I'm pleased with it so far. Now we'll get these mounts thrown back in, get this prepped a little better, throw the motor back in, tack them in place, pull the motor back out, weld them in. And then motor mounts, at least this side, are done. Got a couple tacks on these mounts, and then I realized that this is all the filler rod I have left, and it was even rusty, so I had to sand the rust off of it. Not ideal. Had I known, I would have gone and picked some up, but the closest welding supply store closed literally 8 minutes ago. So I got enough to tack a couple more spots. I think I'm going to go ahead and pull the engine back out, since I've got it tacked in 3 or 4 spots each mount. Pull the engine back out, and then I'm going to pull this subframe out, which is currently just held in with these rear 2 bolts. Drop that subframe, and that's going to give me the room I need to weld this lower tab on here. So probably go ahead and do that. Why not? My little brother got me this surface prep tool for Christmas a couple years ago, and I don't use it very often, but when I do, I'm amazed at how well it works to remove rust and mill scale off these parts and leaves a nice brushed finish. So, thanks, Bo. Whoop! Who saw that coming? Not me. Well, I ended up getting one mount mostly welded in, 90% I'd say. Still got to do the back mount. I did get underneath it too. So I've also created this little cross member here. This is 1x3 rectangular tubing, and I just wanted to kind of see what it was going to look like in there. I'm more than likely going to move it to where it's going to be in line with this guy. And the reason for that is I'm going to put that machined aluminum brace in there, and I want it to be directly tied in. Doesn't really make sense to have it farther forward and have a dog leg, because I'm trying to stiffen up the whole front end. And this will get some threaded bungs welded into it. So like I said, just tacked in place for now. I'll end up moving it more than likely. I'd say I'm about 95% sure I'll move it back just to make it in line, which isn't a whole lot. It's about 3 inches, I'd estimate, that it needs to move back to be in line with these. Whatever these are, I don't know, but I'm going to use it to make a front bulkhead just to tie this whole front end together. And then there'll be some stuff that come off the front here for the front bumper and the hood mount, the grill, all that kind of stuff. But I've officially taken enough front weight off this car to where it is sketchy on these quick jacks. They want to rotate, so I had to throw some jack stands under the back, keep this car from flipping. The subframe is quite heavy. It's heavier than I expected. For this to be such a lightweight, semi-lightweight car, it's got a lot of heavy components, so I have to keep reminding myself not to let this snowball, because I'm already redesigning an entire front subframe, front suspension in my head, and I got to stop that kind of stuff because I'll never get done. I just get in so deep. So maybe later when the car is running and driving, maybe. We'll see. But I do have some ideas. But for now, this is pretty decent progress. The motor hangs by itself. It's very easy to put in and take out. This will be the 4th or 5th time now that it's going in the car. And these little slotted mounts I did work great, because you just leave the upper bolt in, drops right in. Whenever the cylinder head rests right there is when the bottom bolt is lined up. Slide it through, and like I said, I've straightened those bolts out enough to where they go in and out by hand now, so very happy with it. So let's throw this engine back in here.